Hi, class. This is Miss Lazarus. One of your classmates had a question about one of the questions on the review for our upcoming test. And I just wanted to make a quick video to go over it in case any of you guys also have the same question. It has to do with finding the area between two curves. So let's go ahead and just dive into it. So it says in the figure, the equation of the solid parabola is y equals x squared minus 4. The equation of the dashed line is 3x, and we want to determine the area of the shaded region. So a couple things to look at here is here's our parabola, x squared minus 4, and this is the line y equals 3x, the dashed line. We're looking for this shaded region here. Now when we do this, this is an integration problem. Basically, you're going to be integrating the area of the function that is greater than the other function for the entire interval that you have right here. So we're going from this intersection to this intersection here, and we're going to find what those values are, solve for those values. And so the function that's on top is going to be 3x is greater than x squared minus 4 over the entire interval. And so we're going to be subtracting those areas. We're going to take the area between 3x and the x-axis and subtract the area between x squared minus 4 and the x-axis. Let's go ahead and write down that formula real quick. So the area goes from A to B. So our leftmost intersection point is A. Our rightmost intersection point is B. And we take the top function, we could just call that f of x. And we subtract our bottom function, g of x. And then dx. Now what's good about this problem, or I guess easier, is that our function 3x is greater than x squared minus 4, the parabola, for the entire interval that we're going to be looking at the area for. There's just the two intersection points. Sometimes when you have more than two intersection points, you can have one function going on top of the other. Like if this was to go up and over like that, then, you know, the parabola would be on top of 3x for another part of the area, and then we would have to subtract the other way for that. But what's nice here again is that 3x is greater than x squared minus 4 over the whole thing. So let's go ahead and label those. So f of x is greater than g of x on the open interval from A to B. Okay, so this is just the general formula here. So we can just say where this is true right here. Notice I didn't say greater than or equal because we're not actually including the endpoints on that. Yes, they are equal at A and B, those two intersection points at those x values, but I'm just saying that it's greater on the open interval. Okay, so what we do now is we need to find, let's see, A and B, and we need to just label these. So the greater function is 3x, so that's f of x. And the least one is x squared minus 4, so this is going to be g of x. Okay, now let's find A and B. So as discussed in class, to find A and B, you just set your equations equal to each other. So I have x squared minus 4 equals 3x. That's going to be x squared minus 3x minus 4 equals 0. Factoring this is pretty easy. It's just x minus 4 times x plus 1 equals 0. When we solve this, we're going to get x equals 4. We're going to get x equals -1. Now, the leftmost point is -1. That will be a when we integrate. That's our lower bound. And then our upper, the rightmost point is 4. That's b. Okay, so we have everything we need now to plug into our area equation here. So this is going to equal, we're integrating from -1 to 4, f of x minus g of x. So f of x is 3x. We're subtracting g of x, which is x squared minus 4. And then dx, since we're integrating with respect to x. Okay, so let's just clean this up a little bit. So it's from -1 to 4, 3x minus x squared and then minus minus is going to be plus 4, and then dx. That's going to equal, for 3x, we go up a power, that's going to make it x squared, but we have to divide by that power, so we're going to divide by 2. That gives us 3/2 x squared. For x squared, it goes up a power to 3. We divide by 3, same as multiplying by 1/3. So we have minus 1/3 x cubed. For 4, it's just 4 times 1, or we can say 4 times x to the 0. We go up a power, becomes x to the 1, which is just 4 times x. We don't have to write down that we're dividing by 1. That's understood for any number. And then we are integrating from -1 to 4. So this is our definite integral. We do not need a constant of integration in our solution here. We're just going to have a number. Okay. So let's plug everything in. We have 3/2 times 4 squared minus 1/3 times 4 cubed plus 4 times 4 Now we're going to subtract, plugging -1 in. So we have 3/2 times -1 squared minus 1/3 times -1 cubed plus 4 times -1. All right, let's simplify now. 3/2 times 4 squared, that's 3 times 16, which is 48. Divided by 2 is 24. 4 cubed is 64 over 3 is just 64 over 3. So you have minus 64 over 3. Plus 16, 4 times 4. Okay, now we're going to do the minus. So we have -1 squared is 1 times 3/2 is 3/2, so a minus 3/2. We have -1 cubed is -1 times -1/3 is positive 1/3, but it's a minus, so it's minus 1/3. And then we have -1 times 4 is -4, but there's a minus, so it's a positive 4. That's going to equal 24 plus 16 is 40, plus 4 is 44. We've got minus 64 over 3, and minus 1 over 3 is minus 65 over 3. And then we have minus 3 halves. That's going to equal, we're going to need a common denominator of 6. So 44 times 6 is going to give us 264. And we'll just put over 6. Minus the 65 over 3, we're going to have to multiply the top and bottom by 2 to get a 6 on the bottom. So that's going to be minus 130 over 6. And then the minus 3 halves, we multiply by 3 on top and bottom to get a 6 on the bottom. It's going to be minus 96. So simplifying this, we get 264 minus 130 is 134 minus 9 is 125. So we get 125 over 6. And that is the area that we see right here. So the area between the two curves is 125 over 6. Let's go ahead and use the calculator too, just to double check our work. So I'm just going to plug in the integral that I had right here. Of course, calculator's not going to set it up for you, so you have to understand how to do that, but you can always just double check at this point right here. So I'm going to go to math. I'm going to go to number 9, function integration. We're going from -1 to 4. I have 3x minus x squared minus 4 dx. And that gives us 20.8333. It just keeps on going. But that's the decimal form. We want to have the fraction form. So we can go to math and we can change it to fraction. And notice that we do indeed have 125 over 6. So that verifies our solution. Well, that brings us to the end of our problem. I hope this helped if you're having issues with finding the area between curves. I'll see you in class, and thanks for watching.